Hello, we're back for lecture 4 in chapter 6, and here we're going to talk about the difference between real and nominal GDP. Because we have a problem with GDP over time, and again we're measuring production, but the problem is we measure production by prices, and unfortunately in the real world prices don't stay the same. So that means if you want to compare GDP over time, you have a problem, because if you look at nominal GDP over time, it's not telling us very much. So nominal GDP is the dollar value of goods and services measured using the prices that existed in the year that those goods and services were produced. So it looks at the price of the car. Say you're looking at 2019. You look at the price of the car in 2019, and that's what they used for that year's GDP, and that would be the average price of cars during that year. And then they would look at the price of apples during the year, the average price of apples during the year, and those would be the prices that are used each year. But then 2020, the prices will be different, and so you would have nominal GDP would be influenced not just by more production or even less production, but by changes in prices. So this means that nominal GDP over time can increase due to higher prices and or higher production. And typically most years when we are producing more, it's due to both reasons. Nominal GDP would go up because usually we have little inflation in the system, which means we have higher prices, and then you also have some higher production. And so if you want to compare the nominal GDP of 2020 with the nominal GDP of 2019, it's not a fair comparison because 2020 is going to have a little bit higher prices. And so what we want to do is we want to come up with a measurement known as real GDP, and that is the production of goods and services adjusted for price changes. So real GDP can only increase if we experience an increase in production, and that takes out the inflation. So how do we come up with a measurement that takes out inflation? And that is known as using what's called the fixed weight method. With nominal GDP, we always use the prices during that year, but now we're going to use the prices that existed during just 1 year. And those prices are the same year after year after year, so we do not increase those prices. And this measurement of a fixed rate requires what is known as a base year. Now, base year, doesn't really matter what year is the base year, just pick one, and that year now becomes a year we use those prices for all of our calculations. So once the base year is chosen, then those prices that existed during the base year will be used to measure the value of the production of all the final goods and services produced. So for example, if the price of a new computer is $3,000 during the base year, then all new computers produced in all the other years are also going to be valued at $3,000. So no more inflation. An example of that would be down here, and this could be a question on an exam. So what I could do is I could give you two goods. I can give you, say, chairs of milk, and I'll give you some production numbers. So in year 1, whatever year that is, doesn't matter, the calendar year, it's year 1, we have 10 million chairs and we had 100 million gallons of milk. Year 2, we had 15 million chairs and 110 million gallons. And here are the prices that existed in each year. So in year 1, each chair had a price of $200, and that would be the weight for chairs in year 1. And for milk, each gallon was $4. Year 2, each price of each chair was now $400, and then the price per gallon is $5. And again, all these numbers I simply made up. So now what I could ask you on the exam is I could ask you to do some calculations. And so what I'll do is I'll leave this here, right here, so we can see this. There. So what I'll do is I'll say calculate the nominal GDP for year 1. And so what you would do is take the production. You would take, say, the 10 million chairs in year 1, and then you would times it by the price of each chair, which is $200 per chair. And so that would be $2,000 million. Just leave the units as millions, we don't need all the zeros. And then you would take 100 million gallons of milk, times that by each price, which is $4 per gallon. And so $4 times 100 would be $400 million. Add them together, and that would be $2,400 million, or that would be $2.4 billion if you like. And that's exactly how the Bureau of Economic Analysis does it. They simply take the production numbers in each year, times it by their price, and they get the gross domestic product. Now notice that when you do the calculation, we have shares here times dollars per chair, and so the chairs cancel out, and all we have is dollars left over. And so again, your GDP is always going to be measured in dollars. Do the same thing for year 2. We now have 15 million chairs. Times that by the new price of $400 per chair. And that would give us 10 times 400 would be 4,000. 5 would give us another 2,000, so that would be $6,000 million. And then do the same thing for milk. 100 million gallons of milk. You times that by $5 per gallon, and that'd be 550, right? This was a face-to-face class. I'll tell my students always check my math, and that'd be $6,550 million. I'll bring it up now. So again, I took the 50 million shares, times it by $400 per chair, we got $6,000 million, and then 150 million gallons of milk, times it by $5 per gallon. That's per gallon. And that's why the gallons cancel. And then we have $550 million right there. And then add them together, it's 6,550. Now it looks like that maybe GDP has increased dramatically from 2,400 to 6,500, which would be not just doubling but almost tripling. But as you can see, the production is nowhere near that. Chair production went from 10 million to 15 million. That's a 50% increase. And then milk production went from 100 million gallons to 110. That's a 10%. So this really exaggerates the increase in production, and that's simply because we're using much higher prices in year 2 than year 1. So the increase here again is due to both reasons: more production, more chairs, more milk, and mostly I would say due to the higher prices of chairs and milk. I mean, milk prices went up a fair amount by 25%, but look at chair production or chair prices, it doubled from 200 to 400. So that's a problem. These two numbers are not comparable. They tell us nothing. And so what we want to do is we want to come up with numbers that do tell us something, and so that means we want to get real GDP. And so we have two options with my example, because we only have 2 years. We can pick year 1 as the base year, or we can pick year 2 as the base year. Let's pick year 1 as the base year, and then let's do the calculations. And so I paused the video there so I could write out the numbers here, save some time. And the numbers for year 1 are identical as up here. So if year 1 is the base year, that means we're using the prices in year 1. $200 per chair, $4 per gallon. Do the same thing down here. There's no difference. And that's always the case. If whatever year is the base year, both the nominal number and the real number will be the same, because that's the year using all those prices in. Looks like I'm getting a lot of email. It always keeps binging right now. Maybe I should turn that off. Too late now. And then now we have year 2. What to do with year 2? Well, last time we used the prices for year 2, but if we're using year 1 as a base year, we simply use the same prices we had up here. So instead of using the $400 for the nominal GDP, we use $200 here. And instead of using the price of $5 per gallon, we use the number for year 1, which is $4 per gallon. $200 per chair, $4 per gallon. Again, the chairs cancel, gallons cancel. We have dollars left over. 15 million times 200. Well, 10 million will give us 2,000, and then another 5 will give us another 1,000, so that'd be $3,000 million. And then 110 million times 4 would be 440 million. And that would be 3,440. Always make sure you have dollar signs and millions, and that is the increase, or that would be the real GDP for year 2. And now it's a fair comparison. It's still higher than before, but it's not nearly as exaggerated as we did up here with the nominal. And now this is a fair comparison because now we're using the same prices in both year 1 and in year 2. And last thing I'm going to do is take the percent change between those 2 years to see what's happened to GDP. Make it comparable with, say, years earlier or years later. And so the percent change is always the same way. You take the GDP number in the year you're going toward, in this case year 2, and that would be 3,440 million. Because they're all in millions of units and they're all in dollars, we can leave those all off because they're all going to cancel out. So we can just leave it as 3,440. We want to subtract the number for year 1, which is 2,400. Do that first, and then you divide that by your starting number, which is 2,400, and then times by 100 to get the percent. I'll get my calculator out. And so I take 3,440 minus 2,400. I get, sorry, messed up, 3,440 minus 2,400. I get 1,040. Divide 1,040 by 2,400. I get 0.433 times 100 to change that into a decimal, and that would be 43.33%. What does that tell us? It tells us that from year 1 to year 2, we had a real increase in production of goods and services by 43.33%. If that seems high, it's very high. If this was a real example, this is not a real example. All these numbers are made up, and so that number is fine. And to be honest, if your economy is really small, you can see growth rates like that really large. So if you're really a poor economy and you have some kind of a modest growth spurt, it could be really high like that sometimes. U.S. economy, not possible because we are highly developed and we're producing already huge numbers of GDP. Anything over 4% would be almost impossible to achieve these days. And I'll stop there. We'll break up this lecture into probably 3 parts. This will be part 1.